All right, so now that we know what some different types of matrices are and what a diagonal is, what a diagonal entry is, that kind of thing, we can talk about this new idea, something called a transpose of a matrix. A matrix can be transposed by simply converting its rows to columns and vice versa. This is matrix A. It has row 1 with entries 3, 1, 2, and row 2 with entries 5, 9, 7. And I'm going to write A with a little superscript T on it. That means A transpose. And instead of writing across 3, 1, 2 across the top as the first row, I'm going to write it as the first column, 3, 1, 2. And the second row was 5, 9, 7, so I'm going to make that my second column, 5, 9, 7. So what you see here now are matrix A and the transpose of matrix A. That's really all we're going to talk about in this video. So let's just do an example. Let's take a matrix. There we go. B equals 2, 1, -3, 4, 2, 7, 6, 9, 0, -1, -5, I don't know, 4. Okay, and then let's find the transpose of this matrix. This is a 4 by 3 matrix. So B transpose is going to be a 3 by 4 matrix. I'm going to take each row, starting with 2, 1, -3, and write it as a column. 2, 1, -3. The next row is 4, 2, 7. That becomes my next column. 4, 2, 7. 6, 9, 0 as a row becomes 6, 9, 0 as a column. And -1, -5, and 4. So there's B transpose. Now, what do you suppose B transpose transposes? In other words, what is the transpose of the matrix B transpose? Because you'll notice that it is, in fact, a matrix. This B transpose is a new matrix, right? So what I want to know now is what is B transpose's transpose? And the answer is, if I take each row, starting with this one here, 2, 4, 6, -1, 2, 4, 6, -1, and write it as a column, 1, 2, 9, -5, and -3, 7, 0, 4. I get this 4 by 3 matrix, and as you'll see, it's the same as B. So we've got this nice property that the transpose of B transpose is equal to B. All right, let's highlight that because I think that's a good thing to keep handy, a little factoid that we want to keep handy for future reference. Here's another one. I want to look at the transpose of a matrix. I'm running out of room again. I do that to myself an awful lot. Let's go up here. Let's look at matrix D. 1, 0, 0. I'm writing it as columns now. I really want to write it as rows. 1, 0, 0, 0, 1, 0, 0, 0, 1. You'll notice that this is an identity matrix because first of all, it is square. Second of all, every diagonal entry, 1, 1, 2, 2, and 3, 3 are ones, and everything else is a 0. So this is an identity matrix. What is D transpose? Well, I'm going to take the first row, which is 1, 0, 0, and write it as a column. And then the second row, which is 0, 1, 0, 0, 1, 0, and write that as a column. And the last row, 0, 0, 1, and write that as a column. And you'll notice that D transpose, because it's an identity matrix, is equal to D. So we can't always say this. We can't always say that any matrix, when you transpose it, is going to give you the same matrix back. We can only say that with identity matrices. So as a property, I'm going to write that this way. The identity matrix, when you transpose it, gives you back the identity matrix. That's another little factoid I think we should hang on to. So those are two particular, very specific results when we're talking about transpose matrices. That's pretty much all there is to it. So that's going to do it for this video. I'll see you in the next one.